Hello everyone, I am Bhupesh Kumar Devangan, lecturer Government Polytechnic Surajpur. Welcomes you all to the course Essential of Surveying, Application and Technique. Today we begin with our lecture of this course. We will cover the following key points in this lecture. First, the part of total station, accessories of total station, setting up of total station, measurement of horizontal angle, measurement of vertical angle using total station, error in measurement in total station. In the last lecture, we discussed the EDM, that is electronic distance measuring instrument, the basic principle of EDM and application of EDM, and introduction and application of the total station. Let's briefly revise the introduction of total station. A total station is a electronic or optical instrument consists of three basic components. The first one is an electronic theodolite, and the second one is a electronic distance measuring instrument, that is ADM, and a computer or a microprocessor integrated into one unit. Measurement may be taken using reflector or in reflectorless mode. Range varies from 100 of meter in reflectorless mode to few kilometer using reflectors. Time for measuring is 2 seconds to 4 seconds in normal mode. Let us discuss first component of total station, electronic theodolite. Electronic theodolite consists of horizontal and vertical circle, standard, telescope and tri-brach. Electronic theodolite consists of three primary lines or axes. First is the horizontal axis, second one vertical axis, and line or axis of sight. The theodolite consists of two graduated circles mounted in mutually perpendicular plane, that is one in horizontal plane, other in vertical plane. On leveling, horizontal circle is oriented in horizontal plane, which is automatically puts the vertical circle in vertical plane. Horizontal and zenith angle can be observed directly in their respective plane of reference. Let us discuss component of telescope. Telescope is mounted between standards and optical in nature, consists of objective and eyepiece lens, reticle with diaphragm. All are mounted inside a tube. Telescope can revolve about the horizontal axis and rotate about vertical axis of the total station. After leveling, it can aim to any azimuth along any slope to sight a target point. Other part of electronic theodolite is tri-brach. Tri-brach forms the base of instrument for fixing upper part, that is LED of total station with the tripod stand, primarily for leveling and centering of the total station. Also used for making use of different instrument at the same setup to make use of same leveling and centering arrangement. Let us discuss second component of total station, that is EDM. In last lecture we discussed the EDM in detail. Let's briefly discuss the EDM. It makes use of electromagnetic energy to measure distance. It measures distance indirectly, determining the number of full and partial cycle of transmitted electromagnetic energy traveled between the two ends of a line. It measures the distance traveled by electromagnetic energy traveled between the instrument and the target, and that comes back to the instrument. Multiplying the total number of cycles by its wavelength and dividing by 2 yields the unknown distance. The third component of total station is a computer or microprocessor. It controlling measurement and computation done through a microprocessor getting access through a keyboard. Some silent function of microprocessor are as follows: to make circle zeroed instantaneously, to observe angle by method of iteration in either direction, to observe angle by method of repetition, averaging multiple distance and angle observation, reducing slope distance to horizontal and vertical distances, computation of elevation from vertical distance component, computation of coordinate from horizontal angle and horizontal distance component, etc. Body of a total station is divided into two broad parts: upper part, that is LED, and the lower part, that is tri-brach. LED includes standards, telescope, EDM, circle, that is horizontal circle and vertical circle both, and other element for measuring angle and distance. Tri-brach contains foot screw, circular level, clamping device, and threads. Other important part of total station, first one is the automatic compensator. It is assembled in total station to get precisely indexed with the respect to the direction of gravity. It automatically align vertical circle having 0 degree oriented precisely upward toward the zenith. The second other important part of total station is plummet. It built into either elidate or tri-brach. It provides a line of sight that is directed downward, collinear with the vertical axis after leveling for accurate centering. The third important part of total station, optical guidance system. One or two above or below the telescope tube at the end of the objective lens. These are light emitting diodes and emits a visible light pattern which enables detailed pole to be set directly on the line of sight at the correct distance without the need for hand signal from the total station. In some instrument, OGS is that is a optical guidance system is represented as guide light. It is composed of a light that is divided into green and red section. A poleman can ascertain the present position by checking the guide light color as follows. When the light source increase flashing speed, move toward the total station. When the light status decrease flash speed, means move away from the total station. When the light status fast flashing, target at the correct distance. When the light status shows red, that meaning move target left. Light status showing green, that means move target right. Light status red and green means the target at correct horizontal position. Another important part of total station is a communication ports enable external data collector or computer to be connected, used for downloading from total station and uploading to total station. Detailed figure of total station with their part is shown in the figure as below. All the parts are labeled in this figure. From this we can see the various parts of electronic theodolite and ADM and overall a total station. Apart from important components, some accessories are required for working with the TS total station. Some of the accessories are present as integral part of the total station, that is control panel, data collector, memory, etc. Some other totally independent accessories are required like reflectors. Let us discuss control panel. The control panel of a total station consists of a keyboard and a multiple line liquid crystal display, that is in common language we known as LCD display. The keyboard enables the user to select and implement different measurement modes, enable instrument parameter to be changed and allow special software function to be accessed. Multiple function key in the keyboard carry out specific task and some other key active and display menu system which enables the total station to be used as a computer. Further, keyboard also used to code data generated by the instrument. For mapping, if a code is generated from keyboard to define the feature being observed, the data can be processed much more rapidly when it is downloaded into and processed by an office-based computer or plotter. The keyboard and display can be detached from the instrument and integrated with the other total station and with the GPS receiver. This enables data to be shared between different instruments and the system using a single interface. Thus, combination of keyboard and display unit not only controls the operation of total station but also stores the measurement and data. Keyboard contains different type of keys to provide different command to its microprocessor, which is subsequently get work carried out by its different part. It contains different alphanumeric keys, option selection keys, switching keys, power key, lighting key. A glimpse of the important key present in the keyboard of a typical total station is as follows. First button power key to switch between on and off the total station, illumination key to light the reticle key and to select screen backlight brightness, to turn laser point or guide light on or off. Star key to jump from each basic mode screen to the screen of checking or changing the various setting directly. Escape key to control the input data to return to the previous screen. Tab key to shift the next button. Backspace key, which is shown as a BS key, delete a character on the left. Space key, that is shown as a SP key, input a blank space. Function key, that is shown as FUNC key, to toggle between observation mode, screen page An enter key, that is shows as ENT key, select accept input word and values. Numeric alpha keys to input numerical and alphabetic character. Alpha key, input mode key to switch between numeral and alphabetic character. Shift key to switch between lowercase and uppercase alphabetic character. Target key to switch between target type, reflector and non-reflector. Program key, which is shown as PRG key, to switch between program mode and basic mode. Luminance sensor or microphone key. The figure of a control panel is shown in the figure. In this, the all keys are shown with labeled diagram. Other important point of theodolite memories. Total station make use internal memories and memory card for processing the storing information. Internal memory on board storage capacity of about 5,000 to 10,000 codes survey point. Data can also be stored on memory card which are plugged into total station. Data may get exchanged to PC from total station, from PC to total station using card reader. Other important accessories of the total station is reflector. Total station use return or reflected signal for measurement. This is obtained using a specific reflector. Total station reflector consists of special reflecting prism constructed from glass cube or block. Return waves are pulsed along a path exactly parallel to the incident path but within the range of angle of incident of about 20 degree. A wide range of reflecting prism are available to suit short as well as long range of measurement. Single and triple prism set for fixing and tripod stand, mini prism for pole mounted or 360-degree prism for robotic total station are being used. Reflecting prism are associated with a prism constant of order of 30 to 40 mm. Prism constant is distance between effective center of the prism and its plumbing point. Handling and setting of total station. This is our next point in the total station operation, handling and setting of total station. For proper and efficient work as for proper maintenance of instrument, it is very important to handle total station with care. Further, for any field work with total station, it is temporary adjustment should be done properly. This is achieved through an operation called setting of total station. However, before setting, the permanent adjustment of the total station must be ensured. Handling of total station. For proper handling, following points should be taken care of. Lift from carrying case by grasping the handles are standards. For setting, total station should be fastened securely to the tripod by means of tri-branch. For moving between a station, total station should be transported with due care. Before removing from tripod, foot screw should be brought to midpoint of the post. Total station should never be transported on the tripod. It causes stresses tri-branch total station base. Total station should be returned to the case with the all locking mechanism released. If wet, total station should be wiped properly before placing in the case. Tripod should be stored with its legs loose or lightly clamped. And second part, setting up of total station. Temporary adjustment of total station consists of following steps. First step is fixing, second step is centering, third leveling and fourth sighting. Fixing is to place total station over the station in approximate leveling and centering. And centering to make vertical axis of total station pass through the station mark. Next operation of setting of total station is leveling to make horizontal axis of the instrument truly horizontal. Sighting to make image of the object appear at reticle. Let us discuss fixing of total station in detail. The fixing operation consists of fastening of total station with the tripod stand along with approximate leveling and centering over the station. For fixing the instrument, the tripod is placed over the station with its leg widely spread so that the center of the tripod head lies above the station point and its head approximately level by eye estimation. The instrument is then fastened with the tripod by screwing through base plate. The height of instrument should be maintained in such a way that observer can see through telescope conveniently. Approximate leveling will make the circle level bubble near its center. Approximate centering need to be ensured through plummet. If required, the approximate leveling and centering of the instrument over the station is done by moving the tripod leg radially or circumferentially as per need of the circumstances. Radial movement of the leg make the vertical axis get shifted in the direction of movement of the leg without seriously affecting the level of the instrument. Circumferential movement of the legs adjust level of the total station without affecting much the vertical axis. Sometimes the instrument and the tripod have to be moved together bodily for centering. The next step in setting up of a total station is centering and leveling of total station. Leveling of a total station is being carried out to make the horizontal axis of the instrument truly horizontal. Generally, there are three leveling screw and one circle bubble present in total station to be used for adjustment. Thus, leveling is being achieved by carrying out the following steps. In the first step, adjust the leveling foot screw to be center survey point in the optical plummet reticle. Center the bubble in the circular level by either shortening the tripod leg closer to the off-center direction of the bubble or by lengthening the tripod leg farthest from the off-center direction of the bubble. Adjust one more tripod leg to center the bubble. Turn the leveling foot screw while checking the circular level until the bubble is centered in the center circle. Press the power on, indicate the bubble in circular level. The ranges the inside the circle is plus minus 1.5 minutes and the ranges of the outside circle is plus minus 6 seconds. Turn the instrument until the telescope is parallel to the line between leveling foot screw as shown in the figure A and B. Set till angle to 0 degree using foot screw A and B for the x direction and leveling screw C for the y direction, that is vertical direction. Loosen the centering screw slightly looking through the optical plummet eyepiece. Slide the instrument over the tripod head until the survey point is exactly centered in the reticle. Retighten the centering screw securely. If the instrument is leveled using laser plummet, emit the laser plummet beam, check it again. Check again to make sure the bubble is in the electric center circular level is centered. If not, repeat the procedure starting from the step 4 to step 6. Press escape button, return to the observation mode. After exact leveling, centering of the total station should be checked through plummet arrangement, and if not centered properly, exact centering is done using the shifting head of the instrument. For adjustment with fixing screw, first the screw is slightly loosened and total station gate moved until the vertical axis gate placed exactly over the station mark. This whole adjustment gate carried out by looking through the plummet. After the exact centering, the screw gate tightened again. The last process of setting up of total station is sighting. Sighting of total station consists of two broad operations. First one is bisecting and the other one is focusing. To obtain the clear reading, the image formed by the object lens should be fall in the plane of reticle and the focus of eyepiece should also be at the plane of reticle, that is diaphragm. This is being carried out by eyepiece lens followed by focusing of objective lens. Thus, focusing operation involves two steps: focusing of the eyepiece and focusing of the objective lens. Let us come to our next topic, that is measurement of horizontal angle. In the previous lecture, we also discussed with the help of total station, we will measure the horizontal angle. In this lecture, we seen the how we measure the horizontal angle. Horizontal angle are observed in horizontal plane. After the temporary adjustment of total station is done, its horizontal circle lies in horizontal plane and thus in proper orientation for observing horizontal angle. Horizontal angle gets observed directly in the horizontal plane of reference. Measurement of horizontal angle. To measure horizontal angle, two glass circles within the lid are mounted parallel in horizontal direction, one on the top of other, with slight spacing between them. In a leveled total station, the circle get aligned in horizontal plane. Lower circle, that is also called rotor, contains a pattern of equally divided alternate dark line and light space. Upper circle, that is also known as stator, contains a slit slabed pattern which has same pitch as that of rotor circle. A light emitting diode directs collimated light through the circle from the below towards photo detector cell above. When an angle is turned, the rotors move with the respect to the stator, creating alternating variation of the light intensity. Photodetectors sense this variation and convert them into electric pulses and pass them to microprocessor for converting them into digital value. The digits are displaying using the LCD screen, that is liquid crystal diode. Uh, in this figure, we have shown that if we have to measure an horizontal angle, say angle POQ is to be measured, then following steps are required to be adopted to measure the horizontal angle. To observe horizontal angle, say POQ, a total station is directed mode is centered over a station O and leveled correctly. With both the horizontal and vertical circle main screw released, turn the telescope to bisect the object at P approximately using the optical collimator. Clamp both the main screw. A precise bisection is then made to point P and make vertical crosshair placed over the object using the horizontal and vertical circle tangent screw. Make the initial value 0 degree 0 minute 0 second. The next step, unlock both the horizontal and vertical circle main screw and turn the telescope clockwise to take foresight to B. It is done by bisecting Q, first approximately, then precisely done as in step that we followed in horizontal and vertical circle main screw release. Turn the telescope to bisect object point P approximately using approximeter and precise bisection by the tangent screw as we done in test station P. When the foresight is completed, the value of the horizontal angle will be automatically appear in the display. This is the steps to followed in the total station to measure the horizontal angle. First, the total station is approximately adjusted at the point O and switch on the power. Carry out the fine accurate adjustment of total station using the setting out of total station operation we discussed previously. Then accurately setting the first target, that is point P, press enter key to go to the main menu. Select observe and press enter key. In the first page P1 of observation menu, press 0 set, 0 set will be placed, so press 0 set again and bisect the second target, that is point P, moving the telescope right clockwise. The display shows the horizontal angle as HAR. It is an included angle between the 2 points. In this way, we can measure the horizontal angle in the total station and switch off the power. To measure the horizontal angle, method of repetition or method of reiteration is used as discussed in theodolite. Let us discuss the next application of total station, that is measurement of vertical angle. As the horizontal angle is measured in horizontal plane and vertical angle are measured in the vertical plane, the principle of measurement of angle is the same in the horizontal angle and vertical angle, but the difference is only in the plane. Vertical angle are observed in vertical circle. As instrument is leveled, the vertical circle automatically get aligned in the vertical plane. Zenith angles get observed directly in the vertical plane of reference. Altitude angle get computed from observed zenith angle. if we have to measure a vertical angle that is shown in the figure as a POP, uh, first type of angle is elevation angle, that is a angle upper side from the reference point, and the depression angle, that is if the angle to be measured below the line of sight. To measure the angle in the total station vertical angle, the following steps should be followed in the total station. First, approximate adjustment of the total station as by the as we discussed previously in setting up of total station. Then switch on the power, carry out fine accurate adjustment of total station. The next step is accurate sight the first target, that is point P. Then press enter key to go to the main menu. Select observe and press enter key, and bisect the second target, moving the telescope upward or downward as required. If the angle is elevation angle, then we move the telescope to the upward side. If the target is a downward side, that is depression angle, then we move the telescope to the downward side and exactly bisect the target as required. The difference in the zenith angle provide the vertical angle between the 2 points. In this way, we can measure the vertical angle using the total station. After using the measuring the vertical angle, switch off the power. In the last, we discuss error in the total station. Total station should be permanent adjustment before using it for observation. Seldom achieved in practice and give rise to the instrument error in the total station. To be ensured through regular monitoring of instrument error. It is important to determining the magnitude of the error and corrected them. Instrumental error can be measured and corrected using electronic calibration. The first we will discuss the calibration. Calibration is a permanent parameter of total station changes because of mechanical shock, temperature changes, rough handling, etc. Calibration of total station is to be done by the following procedure given in the manual of the instrument. Calibration should be done before deployment of the instrument for the field of observation in the following situation. For the first time when we used total station, if the total station is used after the long storage, if the total is used after the rough or long transportation, if total station is used after a long period of work, and if there is a big changes in the temperature, we have to check the calibration. And we have also checked the calibration regularly for precise work, for regular routine maintained. Before calibration, total station should be in ambient temperature so that the calibration can be accurate. Instrument software automatically apply correction as a calibration parameter get determined. There are various sources of error. Let us discuss each source by one. The lack in parameter adjustment in the total station lead to the following instrumental error. First, horizontal collimation error, tilting axis error, vertical collimation error, eccentricity error, circle graduation error. Regular calibration adopting proper field procedure need to be implemented to eliminate or reduce the effect of these errors. Let us discuss each type of instrumental error one by one. First, the horizontal collimation. It is axial error when line of sight is not perpendicular to the horizontal axis. It affects horizontal circle reading. It increases with the steep sighting. It is eliminated through both phase observation. The next one is the tilting axis error. When horizontal axis is not perpendicular to the vertical axis, this type of error is occurred. It causes line of sight in an inclined plane as the telescope is plugged. It affects horizontal circle reading for tilted sight. It is eliminated through both phase observation and for equal backside and foresight distance. The next instrumental error is the vertical collimation error. When the 0 degree and 180 degree line of the vertical circle does not coincide with the vertical axis, this type of error occurs. It affects vertical circle reading and it is eliminated through the both phase observation. The next instrumental error is the eccentricity error. If geometric center of the graduated circle, that is horizontal and the vertical circle, do not coincide with the center of rotation, this type of error will occur. This type of error are very small, and by taking the average of measurement taken on opposite side of the circle, it is eliminated. The next instrumental error is a circular graduation error. Non-uniform graduation around the circumference of a circle, that is horizontal or vertical or both, cause error in both the circle measurement. These errors are also small and minimized or eliminated by taking measurement at a different location of circle. Permanent adjustment in a total station before using it for observation is always required. The lack in permanent adjustment in total station lead to horizontal collimation error, tilting axis error, compensator index error, vertical collimation error, collimation of the laser point, eccentricity error, and circle graduation error. Regular calibration adopting proper field procedure are done to eliminate or reduce the effect of this error. Let's summarize the today's lecture. As we seen, a total station is a sophisticated electronic instrument used in surveying and civil engineering project. It integrates three main components: an electronic theodolite for measuring angle, an electronic distance measuring device for measuring distance, and a microprocessor or computer for data processing. Total station can measure, reduce, and display and stored surveying data in digitally format and make it highly precise and widely used in the modern construction and the civil engineering tasks. Measurements are taken using signal reflector from reflector. Before any measurement, a temporary adjustment of total station is required. This involving fixing, centering, and leveling the instrument, followed by sighting. These adjustments are done simultaneously to ensure precise measurement. In summary, the total station is a versatile tool that significantly enhance the accuracy and efficiency of the surveying task. And also we seen the how can we measure the horizontal angle and vertical angle using the total station, and what type of error that is occurred in total station during operation. We have seen that, and have we seen how to eliminate this error and make our measurement precise. This is for the today's topic. Thank you.